All right, here's a couple systems of equations. One I chose with decimals and another with fractions. Um, Although you should be comfortable dealing with either of these, it's still often just much easier to get rid of them. Okay, we can clear decimals, we can clear fractions and equations. So just like solving a linear equation and you clear decimals or fractions, the process is the same when we have two equations in these systems of equations examples here. So with the decimals, what we want to do is clear them, so multiply by some power of 10. That would eliminate all decimals. In this case, it's pretty straightforward. Every single coefficient just has one decimal. So we can therefore just multiply everything by 10. Suppose really quick though that, maybe this one was 0.91 here. Well, if I multiplied by 10, this would only have, this would become 9.1. So that doesn't quite clear the decimal, therefore it would multiply by 100. And you cannot just multiply this single term by 100, you'd have to multiply everything by 100. And therefore, these decimals, the 0.2 here would actually become a 20 if that were the case. All right, well, it's not, so let's, get rid of that, but I did want to point that out. So all in all, when we multiply by 10 to both sets of these, times 10 times 10, I could basically ignore the decimal places. The new equations, the new system would become 3x minus 2y equals negative 9, and then 2x minus 3y equals negative 6. Okay, from here, you can use any method, We probably don't want to graph it, so elimination or substitution. As I've said in another video, I prefer elimination. To me, it's just quicker and easier. Doesn't matter which variable we choose to eliminate. They're about the same. I'm going to choose x. So the simplest way to eliminate x in these is if I took equation 1 here, multiplied by 2, and I took equation 2 here, and I multiplied by negative 3. So the new equation 1 would be 6, multiply everything by 2, 6x minus 4y equals negative 18. Equation 2 would become negative 6x plus 9y equals positive 18. And now when I add the two equations together, these x's would cancel. So negative 4y plus 9y is 5y. Negative 18 and 18 is 0. This is a great example for this as well, because oftentimes when we get, we divide by 5 and we get 0 as one of the solutions for one of the variables, oftentimes people will say no solution. But it's perfectly acceptable to have 0 as an answer. So y equals 0, that's okay. Now we go to equation 1 or 2, it doesn't matter, and we substitute y equals 0. You can go back to the original, that's probably the most common, but you know what, we eliminated decimals, let's just use one of these here, So I'll go back to equation 1, but I'm going to substitute y is 0. So I would have 3x minus 2 times 0. I'm going to write it though, I think we know 2 times 0 is 0, equals negative 9. So that's 0, so 3x equals negative 9, and x is negative 3. So therefore our solution is negative 3, 0. I recommend as well when you're starting to do these, always check. Okay, I'm going to avoid the check in the videos to cut out some time. But substitute negative 3 in for x and 0 in for y into both. equations and make sure it works. For this one in particular, we could do it mentally because y is 0 and that's pretty easy. But still, always check your solutions. Make sure they in fact work for both equations. Okay, this next example we have fractions, and often students just dread fractions, and you know that you should be comfortable enough to solve it with fractions, but you know, why make it harder on yourself? Let's just get rid of them. Okay, as you know, capable as I am to do fractions, I would still just clear them. I would rather solve a system without fractions than with. So how do we do that? We multiply by the LCD. The LCD in this first, right, for equation 1 is 15. So we need to multiply everything by 15. So we're changing the way the equation looks. We're not actually changing the equation, right? As long as you multiply every term by the same number in any equation, then you're not really changing it. Okay, for equation 2, that LCD between 2 and 3 is 6. A little better as far as the numbers go there. So our new system of equations, let's see, we would have 3 and 15 would cancel to a 5, right? So if I multiply by 15 right here, I cancel to a 5, so 2 times 5 is 10. So I'd have 10x. When I multiply by 15 here, 5 and 15 cancel to a 3, and we get 9y. And then negative 17 times 15, oof, I don't know that one in my head. We'll go and do that off to the side. So 17, 15, I was trying to do in my head, it's not working out. 8, 255, so negative 255. Okay. All right, next one, again, multiply by 6. I think this one is a little easier to kind of do in our head, so 1/2 times 6 is 3. Negative 1/3 times 6 is negative 2. And then negative 1 times 6 is negative 6. All right, now we have this set of equations, 1 and 2, but no fractions. That's a great thing, right? But nothing readily cancels, or we can't really use substitution either, solving for a variable like in one step, right? I don't have just an x or a y isolated. So I'm going to eliminate a variable again. And I suppose this time I would prefer to do the y's. The only reasoning behind that really is that I have a positive here and a negative here. Otherwise it would be just as easy to eliminate the x. Okay, so let's take equation 1 and multiply it by 2. Okay, all of equation 1 by 2. That way I have an 18y here, right? And then equation 2, I'm going to multiply by 9. That way I have a negative 18y. And when I add those two equations together, when I combine them, we will eliminate the variable y. All right, 2 times 10x is 20x plus 18y. And then negative 255 multiplied by 2, I believe that's negative 510. All right, equation 2, we would have, let's see, 27x and negative 18y and negative 54. Combine these two equations, 47x equals negative 564. Okay, divide by this 47 on both sides. Of course, you're more than welcome to use a calculator as well. That's going to be negative 1, For negative 12, it looks like this should work. Okay. So x is negative 12. Now looking at equation 1 and 2, even the fraction form, it's nice because it would cancel the fraction. It would cancel the denominator. But I would still rather not use a fraction, right? And looking at the 2 here, I'd much prefer to use equation 2. So let's do that. So we have, for equation 2, we have 3 times x, which is negative 12. Okay. Minus 2y equals negative 6. So that's negative 36 minus 2y. Okay, from here we have a single variable. Go ahead and solve, add 36. I'm not going to write every step. Negative 2y equals 30, and divide 2, y equals negative 15. And therefore, the solution, because remember, all of these are a point, like yes, x equals negative 12, y equals negative 15. But if we were to graph that, this is the point of intersection, right? That's one solution. We also say that it's consistent and independent. I'm not too worried about that. The fact that we get one answer, I think, is most important in this.